So far in this chapter, you've learned how to find the area below and above a z-score, as well as the area between two completely different z-scores. The diagram you see here basically summarizes that. But in all of these scenarios, you were given some value of z or values of z, and the point of the problem was to determine the area. But what if that scenario was reversed? In other words, let's suppose that we know that there is a value of z, let's say about right here, in which the area below it is actually provided to you as 0.0400. The key, though, is we don't know what that z value is. So basically what we're doing is we're flipping the script. Instead of, like up here, being given a z value and finding the associated areas, either below, above, or between, now we're given the area and we need to find that associated z-score. Much like the other problems with the standard normal distribution, these guys, where we needed to use the z-table in order to find what we're looking for. And it's no different with this one. We're trying to look for this z-value. We're going to need the z-table. So what I did was I copy-pasted our scenario over here, our curve, of what we're trying to look for. The goal is we need to find an area of 0.0400. In other words, we need to look it up someplace in the table. Just remember that the table along the outsides here, those are where the z-scores are located. That's actually what we're trying to find in this problem right here. Whereas the areas are located in the body of the table, that is what we need to look up. So we've reversed the process a little bit here, which can be a little confusing, but that has to be the goal. We need to find 0.0400, that area, in the body of this table. How do we do so? Well, it's a little bit of a different task than the reverse process, because if you look at the areas listed in the body all the way throughout, there's just a lot of numbers and a lot of things skipped. So there's no guarantee we're going to find the exact number 0.0400, but we're going to try, right? So what I usually do is I just try to find 0.04 somewhere in the table. So for example, I just found it here, right? So I go, okay, can I get closer to 0.0400 exactly? So then I go here. I go, I'm getting closer, I'm really close. And then all of a sudden, I have jumped over to 0.0392. So in other words, the value that I'm looking for is basically somewhere between these two values. I don't actually have that exact area value in the table. The main strategy here is if you can't find the exact value, you want to find the two values that it falls between. Once you find those two values, which we have, I'm actually going to highlight them so they're a little bit easier to read, right here and here. Once we have those two values, then there's a procedure. It's a very simple one. You have one of two options. If the value 0.0400 falls exactly halfway between these numbers, then we end up having one procedure that we're going to use. We'll see that in a second. I don't want to get too far ahead of ourselves. But if this value is closer to one of the highlighted values that you see, either this one or this one, then we choose that value. If very clearly, this number is closer to this one. We therefore ignore the other value that is it's not as close to, and we need to find the z-score associated with this value. Now remember, when we were finding the area value itself, we ended up coming in and down. So now we have to just do the opposite. We have to go the opposite direction. So we now want to go along this line to negative 1.7. and then up to 0.05 to get negative 1.75, which we then can just throw into our problem. And this value should make sense because if there's this little area, this value has to be on the left side of the curve. Therefore, this has to be a negative value. Therefore, in the end, we now know that a z-value of negative 1.75 has an area of 0.0400 below it. I just want to hit the pause button for 1 second here. Note, the only reason that we were able to look up 0.0400 directly in this table was because it was provided as an area below. So remember, everything in this table, no matter what it is, any of these areas that you actually deal with, they're always below areas. So if I'm trying to find a z-score associated with an area, then the only areas I can look up are areas that are below. So if I was given, let's say, an area above, I would have to manipulate that first before I start looking it up in the body of the table. Let's try another unique scenario. Let's say that I want to know the z values that are at the middle 90% of the standard normal curve. So in other words, let's say that I'm just going to make this arbitrary. So I go over here and here, and I shade in this area. And this represents 0.9000. My goal of the problem is to determine this z-value and this z-value. Hopefully you understand that these will be the same z-value but positive and negative due to the symmetry. But nonetheless, we need to find each one. Back to your history with the empirical rule, even though this percentage doesn't fit that. What you did learn in that section is how to divide areas. So for example, if the middle 90% represents this area value, that means that the rest of the area should be this much, because there's a total of 1 in the whole curve. And if we want to know what's going to be in each tail here, then we should be able to take this value and just divide by 2, which is going to give us 0.0500. So we know for sure that this is going to be the case for the areas in each tail. If you look very closely at the left side of this problem, so in other words, just this piece right here, it doesn't look a whole lot different than this piece over here. What are we trying to do? We're trying to find a z-value that has an area of 0.0500 below it. That should be a very straightforward task after the previous problem. Heading to the z-table, we now need to find 0.0500 over here in the body of the table. So again, I'm going to try to see if I can find 0.05. So I see a few of them over here, which go up to the next line, which is here. Oh, looks like I'm getting closer, closer, closer. Oh, I jumped over. Okay, so this is what I'm going to do. I'm going to highlight these two numbers right here, erase everything else, and I now know that this value is between these two. But much like I mentioned with the two different scenarios about what you would do in this situation before, it looks like this number is halfway between 0.0505 and 0.0495. So it's not closer to one or the other. In that situation, when it is halfway between, then what we have to do is we have to consider both z-scores. Let me redraw this real quick just so that it looks a little nicer. So what do I mean by both z-scores? Well, if we take this number, these numbers, and we go this way, we're going to get negative 1.6. But what we're going to do is we're going to go up on both of them between 0.04 and 0.05. So basically what I have is one number gives me a z-score of 1.64, and the other one gives me a z-score of negative 1.65. So how do I find the z-value? Well, if this area value is halfway between these two, that means the z-value should be halfway between these two. So all I need to go perfectly halfway between these, which is going to give me negative 1.645. That means in my results, this should be negative 1.645. Now, before I move on to the rest of the problem, some students struggle with decimals. So they're like, how did you get that so fast, right? Well, the reality is this is the number that's halfway between them, but you could also, on the side, just do negative 1.64 plus negative 1.65 divided by 2. Because that's what you're doing. You're basically just finding the average or the mean of the two values, and that's what's going to give you negative 1.645. Finding the other z-score ends up being a very easy task, only because this is a completely symmetric curve based on the fact that we were talking about the middle 90% here. So that means the other z-score is just going to be the positive version of the negative z-score we already found, which is 1.645. Before we move to the next concept here, there's one thing that I want to point out with either one of these problems. Whenever you give the area below something, if you recall from earlier on in the course, that represents a percentile. So if I wanted to refer to this z-score as something based on this area, you'll note that 0.04 represents 4%. So this value would actually be the 4th percentile. In other words, what value is at or above 4% of the curve? The same thing can be said over here as well. So because of this value, that makes this the 5th percentile. What about this one? Well, be careful here. Remember that you're trying to find all the area below it. So you're going all the way down. So that means there's 90% in the middle, but there's also 5% over here. So that means this would be the 95th percentile. Why exactly am I pointing this out? Because in reality, on the homework, you might see it there, or on an exam, I could possibly just ask you for, let's say, the z-score that's at the 4th percentile of the standard normal curve. So then you would have to process that and go, okay, 4th percentile means the area below it is 0.0400. You would draw that, and you basically would just mimic this problem. But it's another terminology that you should know going forward. Now that you've learned how to find a z-score with an area below it, the next logical step is to find a z-value or with an area above it. In statistics, that actually has a unique notation involved with it. It's actually called z sub alpha terminology. This actually shows up a great deal in future sections and chapters in the textbook, so it's very important that you can see this and know what it means. For example, suppose that I was asked for this value. In other words, z sub 0.025. So if you see this, specifically a variable z with a subscript that looks like some type of area, it is telling you that it wants a z value with an area 0.0250 above it. That's it. That's all it's looking for. So I'm just going to throw a random line over here. And I'm going to draw exactly what it's asking for. So again, this terminology right here is saying find the value of z that has an area of 0.025 above it. And remember, 0.025 is the same as 0.0250. This is called z sub alpha terminology, and you want to be familiar with it. So how exactly do we accomplish this? The first key is understanding that this is not an area below. All of the z table, all of these areas in the body of the table are all areas below. So if you try to look up a number that's not below, you are not going to get the correct result. Okay, so how do I find the z value in this scenario? Then I would have to determine what the area below it is so I can look up that in the table. So I want to know what this is on this side. Remember, there's an area of 1 total in the entire normal distribution curve. So therefore, if I do a little bit of subtraction here, I'm going to get 0.9750 as the area that is below this z value. We can then go to the z table. We need to find 0.9750. Again, that is not over here. That is in the below graph. So I see 0.97 here. So I just keep on going until, and then all of a sudden something magical happens. I actually hit it right on the nose. This is the exact value, 0.9750. It doesn't happen very often, but lucky for us, it happened in this problem. So therefore, all I have to do is go over and up to 1.96, and we now know that this value is 1.96. But just for argument's sake, let's say that you muff this up, which is actually a very common mistake students make. And they decide, one of the students decides to look up 0.0250 instead for this problem. If you go to the z table, that's going to put us at the top. So we already know that we're going to be incorrect in what we're doing here. So if I start looking for 0.02, there's an 81. If 7, 4, 6, 8, blah, 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 5, 6. Oh, look at this. I hit this one right on the nose. And if I look over here, look what I'm going to get, negative 1.96. So in the past, on exams, I've gotten an answer of not the same problem, but it's the negative version of the actual answer. So negative 1.96 is what they circle, and I'll immediately go, look at the picture. Negative 1.96 would not be on this side of the graph. It would be over here. So that answer doesn't make any sense. And that's because they looked up the wrong area. These are the little things you just want to get straight and make sure you understand. That's how you find area above, which often is called z sub alpha terminology. Yet another type of problem in the same genre of area above is one where they might ask, what is the z value at the top 12%? Could be any percent, but let's say it's the top 12%. So what does that mean? Well, remember, percent is another word for area, but not times 100. So this in area is basically 0.1200. So if I want to find the z value with a top 0.1200, then that would put us somewhere on the right of the curve. We would shade this region, and it would be this. So we'd be looking for this z value. Just a small footnote here. Hypothetically, if I had said top like 92%, then that would have put us, even though that sounds weird, it would have put us down here. Because when you say top, whatever that number is represents the area above it. So in order for 90-something% to be above it, it would have been in the back left side of the distribution. Since this is only 12%, then we're in the top part of the distribution. And this also implies that we should get a positive z value. But in order to find this value, remember, all the area in the Z table is below, which means you cannot look up 0.1200. Instead, you need to look up 1 minus 0.1200, which is going to give you 0.8800. Okay, I jumped over to the Z table. Remember, we're trying to find this value in the body of the table. I already see there's a 0.88 right here. So there's a 0.8810 and then a 0.87. So we're already there on the right side of the table, going to highlight. So we're here, and then we jump over to the 0.87 here, which means this value has to be between these two. So what ends up happening? We look at these two numbers, and interestingly enough, again, this number is halfway between these two values. It is not closer. If it had been closer, we would have picked that value or area value. Since it isn't and it's halfway through, we have to use both of these. So we're going to go over here and see that this is going to be 1.1. And if we go up, we're going to get to 0.07 and 0.08. So halfway between that is 0.075. So therefore, our value is going to be 1.175, which we can now throw into our answer to our problem. And just a little bit of a side note here, I forgot to mention before, of course, if this is a top 12% problem, then just like I called this a fourth percentile, I also could have called it a bottom 4% value. Just like here's a top 12%. All of these are different ways to say something similar and something you should be ready for in any type of problem like this.